Hello and welcome back to the Learning Space. I am here with Maarten Roos, and we're going to talk to you a little bit about yet another amazing way that you can interact with science while learning and not necessarily having to be just another PhD astronomer or amateur astronomer on a mountain. In this case, well, Maarten has worked with a team of scientists on what they called a Venus Twilight experiment, and they recorded all of these events for a film about the transit of Venus. He went on to work with one of the sub-teams, by which I mean submarine teams, I think. No, I'm being told no. I was so excited it was a submarine, to go to Svalbard in the Arctic and observe the transit from there. Now, due to the rarity of Venus transits, he's thinking of this film as his legacy for the 22nd century, which is kind of awesome to think about. Now, Maarten, I didn't do the best job in the world at introducing you, so please do a better job and tell everyone all about you. We're having an audio problem. Sorry, fixing the audio problem. No, but I can fix this. I don't quite know what happened, but it's fixable. There we go. Nope, it didn't want me to select that. Okay. Let's try that again.
So, can you hear me now?
Yep.
All right. So, Pamela, thank you very much for having me on your show. That's very kind. And hello to everyone who is listening in at the moment. I can see the messages coming by here, the chat coming by at my left-hand side. Thank you for introducing me. Indeed, yes. So I have been working on I've made this film about the Venus transit, the second one in our series, so to say, our pair of Venus transits. Right, there was one in 2004, and then the other one in 2012. And as you might know, these transits appear in pairs, and the pairs are separated by either 105 or 121 years. Right, so we were very, very lucky to actually see the transit.
Yes.
In our lifetime, because there are people who have not seen it because they just missed it out. But going back a little bit, so I am a filmmaker, a freelance filmmaker, focusing mostly on, not exclusively, but a lot on scientific topics, technical topics. So I'm doing factual filmmaking. I don't make any fiction movies. I mean, at least not yet. Who knows? But before that, I was a full-time astrophysicist, actually a planetary scientist, to be more exact. So, I got interested in astronomy when I was a kid, then wanted to become an astronomer, did the whole, studying at the university, trajectory, a PhD, the whole thing.
Uh-huh.
And then finally, PhD in planetary science. And then finally, I got a position at the University of Lisbon, Portugal, where I worked for about 10 years, a little less time. And after a while, this was now in 2006, approximately 2007, I got a little bit bored of that, in a way. Started to look for other things, and filmmaking sort of happened to me. And so I took this up. I dropped the academic career. I took up the more rocky road of freelance work as a filmmaker, and I have been doing that since 2007, really. However, in the meantime, science has found me again, without me looking for it. I have been doing the past couple of years, in addition to filmmaking, also science contracts, in a way, also on a freelance basis, but a couple of contracts, a couple of projects I've worked on in the past few years. So at the moment, I'm a bit of both, and it's actually a very nice combination, really, to be able to do both science again and filmmaking. And so that's where I am now. And the Venus film was indeed, as you say, a little bit a very special project, right? Have you seen the transit yourself? Did you see the transit yourself?
I saw the second one. The first one, I had a misfortune. I was trying to cover it for Sky and Tell, and because Boston got it for an hour less than Nova Scotia, I went up to Nova Scotia, and we observed clouds. We actually observed little baby bald eagles attempting to learn to fly with a telescope set up underneath a giant beach umbrella. So we were ready. If there was a patch in the clouds, we were totally ready. But it turns out that astronomical telescopes that you have a white light filter on the front of, you can pull that off and observe baby eagles, which, while not Venus transits, still look cool through a telescope.
That's pretty good. Yeah, of course. That's the life of an astronomer, right?
Yeah. Now, it says something about how hard it is to get jobs, get funding, and keep going as a researcher in astronomy when your backup career is filmmaking. Have you ever considered just how amazing it is to going from being one of the one in a million scientists studying planets on Earth to instead being a filmmaker who's successfully making movies? You've had an amazing life.
So the problematics are indeed a bit the same. First of all, there are not a million planetary scientists.
No, it's 1 in a million people on the planet are
Right.
Yeah.
Now, our science community, planetary science, is not that large.
Right.
The astronomy community is not that large compared to, physics or what have you, other fields. The difficulties are a bit the same in a way. First of all, there's always the money question. Ideas are always easy to find.
Yeah.
Ideas for making films, but finding the money is often the difficult part, as with science research. And then, of course, the whole process has a lot of parallels as well. Right? You start an idea, you start to develop it. Then you start to, if you get the money, or if you get some money, you start to do observations in astronomy, or you start to gather maybe interviews or images. And then when you have the data, so to say, you start to treat the data and look at what's in there. And as a film, you start to look into your materials and start to edit it and reduce the data if you wish. And then in the end, you publish something, right? Be it a paper or a film. Right? So there's a lot of parallels there. And so it's a creative process, right? And of course, it's kind of makes me think when people apply for money for science, you have to write out the proposal, your ideas, and you're going to do this is the idea, and we're going to follow this and this plan, and then we'll find this, or we hope to find this and that. Of course, that's very nice, but science you cannot predict. The most interesting things are always off the tangent of what you think you're going to do. And I think with filmmaking is also a little bit the same. Sometimes you're going to make a film in this direction, and when you get the material, especially the documentary type of film, and often you do not really you don't really know what's going to happen. You can, a very different film can suddenly form from the one that you had in mind. And that can sometimes create tension between, if you have somebody commissioning a film.
Yes.
If you have somebody paying for your science. Science may be a little bit less, I don't know. But anyway, this particular case of the Venus film, I got some support. I got support from Europlanet. I got support from, who else did I get support actually? Europlanet mostly, yes, it was Europlanet. And then I also invested my own time and money in the form of time into this project because I really wanted to make this film because it's unique. It's only one literally once in a lifetime. You can do it.
Now, let's step back a second for those who don't understand the science behind why the Venus transit is so rare, and exactly what it is. Now, the what it is quite simple. It's 4 days from our perspective here on the surface of the Earth, the planet Venus, in a fabulous alignment of orbits, gets between us and the sun. And the reason this doesn't happen every month is the sun doesn't take up that much space on the sky. Venus's orbit is a bit tilted, and most of the time Venus appears to go above or below the sun as we see it from our own tilted orbit here on the planet Earth. Now, twice every long period of time, things change and all these orbits line up just right. Now, can you add some details for our audience?
Yes, exactly. So twice. So those orbits come, or those occurrences come in pairs, as you say, right? And they're 8 years apart, always. And so there was one in 2004, and then another one in 2012. And then they're the same months also. There's actually, and then those pairs, as I said before, they're separated by 105.5 years or 121.5 years. And so the next pair will be in 2117, so 105.5 years. We had 2012 June, 2004 June, 2012 June, and then 2117 will be December, and 2125 will be December, and then it will be 23 and so on.
So
there's, go ahead, sorry.
So there's a minor chance that a newborn or a toddler that was around in 2004 will live for the next one, but we're talking like 2 people on the planet Earth might have that benefit.
Yeah, well, you don't know. The medical science is, you never know. But let's not take chances.
That's true.
So anyway, of course there were a few before, right? And so the previous ones were in 1874 and 1882.
Yes.
So end of the 19th century. And now, and the current one, our ones, so to say. Of course, there's a huge difference in technology in that 120 years. It's really, I mean, the battery of instruments that we have now, they could not even dream of course, in the end of the 19th century. And then before that, it was 1761 and 1769. And before that, there was only one of the two in 1639 that we know somebody saw it in the UK.
Now, we know that all through history, people have been watching the planets, with Venus, the morning star, the evening star, being one of the most watched objects in the sky. Mm-hmm. How many of these prior transits do we have any observational records of?
So the first observation, you mean from the transits, right? So
yes.
The first actual observation that we know of, that there is a drawing, that there has somebody looked at it, was James Horrocks. James, I can't remember if it was James, but something with a J, in England. He was a very young fella, and it was 1639. But there we have basically one observation that we know of, at least. And then of course, in between that 1639 and the next one, 1761, there was a realization that this is happening, and also that this could be very useful.
Yeah.
Because one of the big questions at the time was the size of the universe, basically the size of the solar system. We'd figured out that for example, the relative distances between the planets had been known for a while from Kepler. And so we knew if the Earth is at 1, then Jupiter's at 5, Saturn at 10. We knew that, right? That was figured out. But what was 1? We didn't know.
And the way that they were able to do this is by positioning people north to south along the planet Earth. And as they were north and south, what what changed with what they were able to see?
So basically, it's the easiest way to actually really experience that is to do it yourself. So basically, north and south. So what you have is you have the sun on one hand, you have the Earth on the other hand, and you have Venus in the middle, more or less, a little bit, closer to the Earth. And so that's the same. If you take your two eyes, you take your finger and you hold out your finger, or you hold that out, and you hold it out in front of you, and then you look where your finger or your Venus is, your planet there on the image is relative to the background. Say you look out of the window. I've got a window here, and I do that. And if I close one eye, I will see my finger in a different place relative to the background than if I close the other eye. If I look with one eye, I see it different.
And I would normally be able to do this as a demo, but I destroyed my arm falling off a bike. So I'm trying to figure out how to make this go.
But anyway, anybody who is at home doing it, you can just hold out your finger like this, and then you will see, even if you look at your computer, if you close one eye, if you open one eye relative to the other, you can see that your finger will jump, so to say, relative to the background computer or the background image, whatever you have in the background.
And
that's the parallax principle.
Yeah. And one of the ways to quickly and easily demo this, if you have two arms, is you can hold up a background sun, you can hold up a foreground Venus, and then adjust the height of your camera up and down. And as your camera goes up and down, you'll see Venus go up and down on the surface of your sun.
And that's exactly what happened. And so the further your observers, in this case your eyes, would be apart, the larger the jump and the more accurate you could measure, the angle between the two positions. And if you know the distance between the observers or your eyes in this case, you can work out the distance to your and that's exactly the plan. And so in this case, the eyes are two observers, the head is the Earth. So put them as far apart as possible, and look at the background is the sun, and try to do observations of where exactly on the sun's disk is Venus passing. And then you have to compare from both observers these observations and see if you can figure out how different they are, and measure the angle. And since you know the distance between the observers, from that you can then work out the baseline, and you can work out how far Venus is. And that was the experiment that they tried to do in 1671, 1669. 1761 and 1769, sorry.
And at this point, we had already mostly figured out the size of the Earth thanks to being able to use shadows. And it was initially measured in camel strides, and we got more accurate over time. So we have from our audience, Larry is asking, is the pair of transits separate across the sun so that the first is in the north and the next 8 years later is in the south, or maybe something different?
On the sun's disk itself?
Yeah, so what are the similarities and differences between the 8-year pair?
That's a very good question. I don't really know how to answer that because I don't know.
And that's okay.
Yeah, I don't really know. That's. I would imagine that. I don't know. I would imagine they're quite similar between each other, but I don't know. I would have to look that up. I don't know. Sorry.
One of the things I like to tell our audience is scientists don't actually know everything. We just want to know everything and try to know everything. And that's what drives us to do science, is trying to answer all the questions we don't know. So Dat Dolphin is asking, when making a movie with such a theme, how do you balance between scientific findings and the people's lives involved in their discoveries?
That's a very good question. I really like that question because, of course, science is a human activity, and so you can do different things. If you make a film about something, you can just talk about the science,
Yeah.
and then it will become a science film in a way. I mean, it will be about science, or you can talk about the people, or have the people be more involved. In my films, I really like to have that balance, because I really like to show, being a scientist myself, I would like to show that scientists are just human beings, and they can go to a bar and have beer, maybe, or wine, or something. They can be fun. and they're just human beings, and this is a real human endeavor. And so I try to show that in my films. So I try to balance that. And of course, it depends on your target audience as well. If you're talking to a scientific audience, if your film is if I make a technical film, instructional film, I've made an instructional film for medics, and we don't care about, or not much about, the human aspect. We care about how to do this or this or this, and it's a scientific topic. So of course, most of my films have been documentary style and for a broader audience, and then the human factor connects. It is a way to connect between the audience that is not necessarily scientific or scientific by profession.
And with some of the locations you go to, that adds a human aspect, I'd guess. Svalbard is one of the remote.
Get there.
Yeah. So, what did you personally have to endure trying to capture both of these transits?
Well, so the 2004 transit, I didn't. 2004 transit, I didn't film.
Okay.
I wasn't a filmmaker then.
Okay.
I did see it because it was visible in Europe.
Okay.
The 2012 transit wasn't visible in Europe, except for the lucky fact that it was during the summer.
Right.
And so it wasn't visible in most of Europe, but yes, if you would go above the polar circle. So hence we went to the Svalbard, which is an archipelago that pertains to Norway. Mm-hmm. And it's at 78 degrees north, approximately. So well above the polar circle. So you have the polar night in June. It was in June. So actually, Svalbard is an easy place to get to. Okay. It's one of the easiest places to go to if you on any Arctic environment. There's an airport. It's the northernmost everything. You have the northernmost airport, the northernmost university, the northernmost ATM machine, the northernmost disco, the northernmost supermarket. Everything is northernmost because that's what. So it was kind of easy to get there, really. And I had been there the year before, which was fun, for a film that had nothing to do with it, for another film that I made that's online. You can see it on my website. It's called Between Mars and Svalbard. Okay. And it's about a group of Portuguese scientists who go to Svalbard to do field work, to look at specific terrains that you find in the Arctic and then compare it to similar terrain you find on planet Mars and make a comparison. So I had been there the year before, about the same time period. So yeah, I sort of knew what I was going to find there. It's kind of fun. But it's not a location you go to like on your holiday every year. I mean, maybe some people do. I don't. But no, it's easy. It was kind of easy to get to. The fun part, I think, is the northern night, or the night that is in the night. Like it's just daylight. How that affects your physiology or your way of functioning at that time. So it wasn't very cold either. I mean, it was like 5 degrees Celsius. What is that? 40, 45 Fahrenheit.
It's reasonable winter's day.
But yeah, it wasn't very cold or windy, so it was kind of comfortable in a way.
So no polar bear sightings.
No polar bear sightings, and that is an issue.
Yeah.
There are 3,000 polar bears. I don't know how many there are now, but a couple of years ago when I went there for the first time, there were 3,000 polar bears, which is about twice as many as there are people.
Yeah.
They roam around and they come into the village sometimes. Yeah. And so when we were in Svalbard the year before and doing field work, the scientists would go out in the field and do measurements and everything. They had to take a course shooting rifle handling. just in case. So somebody had to have a rifle,
Yeah.
because just in case.
Yeah.
But we didn't see him.
Yeah.
Probably.
There are many cases of polar bears desiring to eat scientists, but you weren't one of the scientists.
No, we got lucky with that one, I guess.
Now, so while the Venus Transit movie is going to be your legacy of the 22nd century, it's not your only film. As you said, you've done Between Mars and Svalbard, and people can find your films at lightcurvefilms.com.
That's right.
What kinds of things have you done? Are you looking to do? And where do you find your inspiration for what would make a good film?
Oh, that's a good question. So one of the first films I did was for Europlanet, this European Planetology Network.
So to back up and explain what that is, Europlanet is a organization that receives a large sustaining portion of their funding through an EU council grant. This allows them to run yearly conferences. This allows them to fund a variety of different grants for science and educational programs. And it allowed you to get funding for your films. So this is EU funding.
It's EU funding, indeed, yes. So I did the very first film, a little promotional film back in 2006 for them, and then a little bit from one came the other. Now, of course, I started in 2006, 2007 making film. 2009 was the year of astronomy.
Yes.
The International Year of Astronomy. So I wanted to do something. And being Dutch, I wanted to do something with Dutch astronomy, because Dutch astronomy, Holland is a small country. As you know, you've been there, so you have been there, if you were there mostly. But in astronomy, it's quite famous for astronomy.
Yes.
And so I wanted to do something around that theme, and then I ended up making a film about the discovery of the structure of the galaxy. So the structure of our galaxy, the Milky Way galaxy.
Yeah.
Right, which was really, really seen for the first time in the early 50s using radio astronomy techniques, which had just been developed at that time, just after the Second World War. And the Dutch astronomers at that time, including Jan Oort, who was a very famous name, and Henk van der Hulst, they did this. And so I ended up making a documentary about this topic, based on 4 interviews with people who actually did things, who were actually involved at the time. And so it became a bit of an historical document, because 2 of the people who are in the film passed away in the meantime. They were already older, of course. So the fun part of it is that, so actually the radio telescope that was used to make the first map, the first sort of sketchy map, where you could actually see the spiral structure of the galaxy, that first telescope was a German spin-off, was a German leftover from the war. And so literally turned the weapons into a plow, right? So they turned a defense, basically a radar defense system from the Germans that the Germans had along the European coast. One of these instruments was turned into a radio telescope and used to observe the 21 centimeter hydrogen line, with which you can then actually map, the spiral structure of the galaxy. And this radio telescope doesn't exist anymore, but the spot, of course, where it existed, where it was at the time, is still there, in the east of the Netherlands. And well, I won't tell the whole story, but too long, but in the end, we had a couple of years later, we had a memorial board. There is a memorial board, and I recently saw it, because recently I was in the Netherlands. There's a memorial board there on that spot where the telescope stood, thanks to the film. And the memorial board explains the historical importance of the site, and has a little QR code, and you can post a little video where it explains a little bit more. But it's kind of cool. But it was sort of my first astronomy film, and then came Between Mars and Svalbard was the next sort of bigger film, I made a film about Virtis, one of the instruments on board the Rosetta spacecraft.
Mm-hmm.
Also flew on other spacecrafts. It was a more technical film, I guess, but we're focusing a lot on the people and the sort of the human story behind building an instrument. Because that's one of the stories you hardly hear. Right? So I'm interested in these stories that are hard to find. So building an instrument, that's not a documentary. A TV wouldn't commission following scientists for years. How are they building an instrument? That's not mainstream. Considered a mainstream interest, which it probably isn't, but it's interesting nonetheless if you're interested in that.
Well, and some of the more successful documentaries recently have been along those lines. Particle Fever a few years ago told the story of the Large Hadron Collider and told it through the eyes of not just the scientists but also the graduate students who constructed it. And
right.
And it turns out people want to know the stories of the people. And
yes, I think there's more and more a tendency in that direction, which is good, because it takes science a little bit out of the realm of the scientist up his tower, the lonely tower, and being just one of us. I mean, being just it's a job. It's an interesting job. Yeah. We don't know everything. Try to seek answers. We're just curious among us. The more curious. Everybody's curious, of course, especially our audience who is here online, of course. But I mean, we are lucky as a scientist. We are lucky that we somehow found a way to actually make that our work, or at least part of the time.
Now, in the chat, Adam Altogether is saying that he likes the image of a telescope on an elephant in your film.
Yes.
I haven't seen that particular scene. Can you describe exactly how a telescope ended up on an elephant?
Yeah. So I followed these scientists. But this was a project called the Venus Twilight experiment.
Yeah.
And that was basically run by Thomas Wittmann and Paolo Tanga, who are two astronomers, planetary scientists from France.
Uh-huh.
So they built a team of how many? 10, 12, 15 astronomers. I don't know the exact number, to be honest. And so they were sent out to different places on Earth to observe the transit, to have the best chance to observe the transit. A little bit like the expeditions in the 18th century, right? Where people went to all sorts of places, different places to try to observe the transit as widely separated as possible. And so one of the teams went to India to observe it from there. And so this is actually the Portuguese team. And Pedro, he talks about his experience there, that he that his Indian colleagues suggested that he would rub the trunk of the deus of the Ganesh, which is the goddess that is an elephant.
Yes.
I think I'm saying it correctly, I hope. That would bring luck to observe the transit. And so he did, and he promised that if they would observe the transit and if it would get good data, then he would take the telescope up onto the elephant and take the picture. So they got good weather and they got some good data, and so hence they found an elephant, mounted it with a telescope on the back, and took the picture. Hence the story.
No, we have a fabulous comment from the chat where it's pointed out that this is like the Sophia Airborne Observatory, but really low tech.
Really low tech, yes.
Now,
the elephant could fly.
So I have a couple final questions. The last one I'm going to ask you is what you would say to someone who wants to replicate your career. But before I get there, I have a couple simpler questions. So when you were a kid, I know a lot of astronomers started out as hobbyist astronomers. A lot of planetary scientists started out as people who read all the books. For filmmaking and planetary science, were you that kid with a camera who was also out there with a telescope, or has this just been a walk through your life where new interests came in at different points?
Yeah. So I was always the kid with the telescope, that's for sure. But I never had a film camera. I had a photo camera.
Okay.
I was with schools, with my classes, photographer and everything. So film really came later. Actually, I was never particularly interested in film, as making film. I didn't have any experience when I started, or particular experience. So that sort of happened, really. It sort of struck me, and it's going to be cool. And then I did a workshop, and the film workshop had nothing to do with documentary or science. It's a 1 week film workshop, and because I knew camera, I knew photo cameras. So it's different; it moves, so you have different things to think about. But still, it's you have a camera. It's a lens. It's framing. It's things I was kind of natural for me. So.
And lighting is the hardest, no matter what kind of camera you use.
Lighting is always hard. It is, yes, it always is. And of course, I'm also very lucky in a way, because had I been 20 years younger or 30 years younger, I could not have done this.
Why do you say that?
I mean, the technology is so enabling now. You have the prosumer cameras, which are low-end professional cameras that you can actually buy as an individual. That they're expensive, but they're affordably expensive.
That's true. Yeah.
And you can carry them with you. And of course, everything is in one bag.
Yes.
Well, almost one bag. I mean, I can edit on this machine here. I do all my editing on this computer, which is kind of scary to think about. Yeah, right. I mean, the technology is so enabling that people like me can actually be a one-man band, or almost one-man band. I like to work with other people if possible. Often the budgets aren't really there. And so it's possible. And 20 years ago, or 30 years ago, this wasn't possible. The technology didn't exist, or it existed, but it was excessively expensive.
So essentially, technology has opened up the doors for dreamers to create their documentaries without going broke.
Absolutely.
That's really kind of an awesome perspective I hadn't had. As a podcaster and a streamer, we've seen very much the exact same thing going on, but it's easy to forget that even with the old traditions, such as documentary filmmaking, the high-tech boom has opened doors for so many new creatives.
Absolutely. And the old creatives using new technologies in a different way as well.
Exactly. Now, you've had what, as far as I know, is a very unique career that has bridged across very different worlds. If someone wanted to quite purposefully have a career that allowed them to combine their research work, their desire to tell the story out there as a documentary, like so many of us do as podcasters, what would you tell them to make that extra step, that extra distance into filmmaking?
It's a tough one.
Yeah.
It's always a tough call, because as soon as if you say you have a science, I had a science position, I had a position at the university, I was kind of safe in a way. So going freelance is always tricky.
Yeah.
Because freelancer, you never know when you're going to get the next assignment, and you never know when you get the next bit of money coming into your account to actually live. But that's really tricky, and it takes time. And especially, there's a rule of thumb by saying, I think people say it takes 3 years.
Yeah.
To try something out, and if it doesn't work after 3 years, you have to dump it because it's not functional. I mean, it's a rule of thumb.
Yeah.
And I think there's some truth in that. It takes a couple of years to get clientele going. So that's tricky. So the best is to have a launching client or a launching project that you can work on, and sort of do it a little bit, maybe start it up while you still have something else going on.
Right.
But otherwise, I mean, it's hard, because just do it, I guess. If you really want to do this, then just do it. And that's go and try. If you don't try, you'll never know, of course.
Yeah. In podcasting, we have two sayings. You're not actually a podcaster until your content is live.
Right.
Because there are so many people that record episode after episode and they never see the light of day because they're waiting for perfect. Perfect never comes. And then the other thing that we always say is you have to keep showing up. If you just keep steadily producing content and learning your craft, you'll build the audience while you're building the quality. You can't start out horrible, but you will improve over time. And you have to keep showing up.
In filmmaking, we say you don't finish a film, you abandon a film. A film is never finished, it's abandoned, which is kind of true, I guess. And you have to just keep going.
Yeah.
Keep going and just, and in the beginning I tried a lot to get my films to the film festivals, and it's very hard. There's a gazillion film festivals out there, but there's a lot more times gazillion filmmakers making even more films, so getting your, but it's not, you just have to go on it. And people criticize, it's good, take criticism, but you decide, but you take the criticism. You listen. Yes. Always listen, because everybody is in the field of creativity, and there it's a little bit different, I guess, with science. Because if you publish a paper, it's peer reviewed, there's sort of truths, you hope, to it. When you make a film or a piece of other art, every viewer every member of the audience is a specialist, because he or she likes it or not, and finds this or that, and that's fine. That's all these opinions are valid. And so you just have to live with that as well. I do my thing. If you don't like it, don't watch it. I don't know. But there's that.
So if you could get infinite funding to do a film on any one passion project, what would that be?
Well, I still want to make my film about the discovery of Neptune.
That would be amazing. That's one heck of an amazing story.
Amazing story. And it has, as far as I know, it hasn't been told.
I don't think so.
Properly. There have been shows about it at BBC, I'm sure. But, that would be an amazing story. But, I'm not giving up on that one.
Well, here's to hoping that film is in your future. Now, if people want to follow you, watch your films, I know they should go to lightcurvefilms.com. Where else should they track you down?
So I have a YouTube channel, should be on there, and my Twitter. I'm on LinkedIn. People are on there. So people can go there. I guess, but Light Curve Films is probably the best point of departure, and most of my work is on there in the portfolio, and then it goes automatically to YouTube channel. Because some of my films are on Amazon Video, so if you have Amazon Prime, assigned to Amazon Prime, you can find some of my work on Amazon Prime, and you can just watch it.
That is awesome. So, I'm not seeing any questions coming in that we haven't already answered. Right. This has been a really good interview.
Is Henny from the Netherlands? Is he from Henny's Voorwerp?
So this is someone who has a username after Hanny van Arkel.
Oh, okay.
But it's not Hanny van Arkel herself.
Okay. What of the discovery of Neptune? Henny asked, what of Neptune? But Larry.
Larry answered. So an animal together is piping up hooray for Leverrier. I don't speak French. Okay.
So I made a short film when in 2011, in July, November 10th or something, 2011, Neptune had completed exactly one orbit around the sun since it was visually discovered. And so I thought it was a good hook. Anyway, I made a little sort of intro film at that. I published a little intro film at that time. You can find it on my website as well. Project.
So Henny is reminding me of one final question.
Okay.
Can you learn anything interesting about Venus scientifically during the transit?
Yes, good question. Actually, the date, from that particular experiment, the Venus Twilight experiment project, the data is still not fully analyzed, and I still hope that I can have a hand in that. I did already do some work, but with the finances, I have to have some more money to do the rest. But so what we want to learn with that, so in the past we learned about the distance, the size of the solar system that the Venus transit will be good for. And this transit, what we looked at, the Venus Twilight experience, looks at the just before and just after Venus goes in front of the sun, but really just before, like 10 minutes or 15 to 10 minutes. The light from the sun is being refracted through the atmosphere of Venus, and you see like an arc of light that changes as the Venus moves closer to or away from the sun. And that the altitude where that happens is an altitude that's very difficult to sound normally, but to probe normally. And so from studying how the light changes as a function of time and a function of latitude of Venus, we can learn something about the temperature and pressure in that altitude region, which is kind of interesting. But we haven't gone that far yet. But there is a talk by Paolo Tonga that I filmed from the DPS 2016 that's also on my website under the same. And there's some preliminary results, so you can take them.
Awesome.
Okay.
Well, thank you so much for joining me, Maarten. I look forward to seeing you at more and more conferences in the future. Are you doing anything for IWA 100? IAU 100,
no,
rather?
I'm not. Not that I know of, not yet. I did a film for AMA 50.
Yes.
Astronomy and Astrophysics 50 years, and made a 15 minutes, actually a 15-minute documentary and a 1-hour documentary. 15-minute documentary you might have seen if you were at the IAU last week or 2 weeks ago. The 1 hour will be next year. But I don't know about AAU 100. They haven't contacted me yet.
Okay. We are all waiting and hopeful for you. And thank you so much for joining us. And thank you, audience, for being here and bringing your questions and being supportive as always. And tune in next Thursday. We do switch times to benefit both Europe and the Asia Pacific region. Next week we will be at 9 p.m. Eastern, which is 11 a.m. Sydney, bringing you Learning Space. I don't have in front of me who the guest is, but I'm guessing that someone from the Weekly Space Hangout crew, Susie, Nancy, Guido, will be posting all of that information for all of you. So come back 9 p.m. Eastern, 11 a.m. Sydney next week, and we will be bringing you more stories with Learning Space. As always, we have at 1 p.m. every day Eastern Time here on Twitch, The Daily Space. That's 6 p.m. London. And we are generally here to put science in your brain. This is a collaboration of the Astronomical Society of the Pacific, Planetary Science Institute, and Youngstown State University. And all of us invite you to CosmoQuest.org, where you can help map out other worlds. So thanks for being here, and wherever you are in the world, remember, go out, look up. Have a fabulous morning, evening, or afternoon, wherever you may be. And thank you so much, Maarten, for being here.
Thank you very much to you, Pamela, to all your team, and to all the people online. Thank you.
Thank you. Bye-bye.